Products that dissolve in the mouth within a short period of time are quintessential for two major populations: infants and older adults with dysphagia or swallowing issues. Eating and swallowing is a complex process that requires precise motor control of multiple muscles to get the food bolus through oral, pharyngeal, and esophageal phases of swallowing. Infants are still perfecting their motor controls, so they often struggle with eating and swallowing foods, which requires coordination of over 30 nerves and muscles, while elderly experience a reduction in their motor controls. The need for an easy-to-consume snack product for both populations is evident. The current market of in-mouth dissolving snack products is carbohydrate-based and greatly lacking in ability to be a good long-term satiety source. The extrusion process begins by turning on the computer system of the extruder and letting the equipment warm up. Once everything is set, the dry feed is dumped into the hopper of the extruder. The dry feed then flows into the premixing cylinder, then down the chute into the barrel of the extruder. As the dry feed flows through the barrel of the extruder, which contains two rotating screws, the dry feed is mixed with the water to form a dough. The temperature of this dough should be around 85 degrees Celsius. Once the extruder conditions are stable, the pressure of the die head can be increased to around 1800 to 2000 psi, and the supercritical CO2 can be added to the product. The supercritical CO2 acts as a blowing agent and results in product puffing. The advantage of using supercritical CO2 extrusion for this process is that we can get a high milk protein based product without causing heat damage due to lower processing temperatures. And using either skim milk or lactose hydrolyzed skim milk in combination with milk protein concentrate powder as the primary ingredients in these fast dissolving puffs, a product can be made having the ideal nutritional profile either for infants or older adult population. The dissolution properties of the exudates were evaluated as a measure of change in compression distance at a constant force using a texture analyzer. The disintegration test setup consisted of a cylindrical plastic probe and a metal cylinder dish. The exudate was placed in the center of the metal dish and the probe was lowered to be resting on the surface of the exudate. The test was initiated, force was stabilized, then the exudate was immediately submerged in 20 milliliters of 37 degrees Celsius deionized water. The volume of the deionized water was maintained around 20 milliliters to create a layer of water over the entire surface of the exudate. The deionized water temperature was maintained at 37 degrees Celsius as to mimic the temperature of the human body. A distance versus time curve was created for each test. The MPC skim milk, and MPC lactose hydrolyzed skim milk samples all had faster disintegration rates compared to the market sample, yet they had a slower end disintegration time than the market sample due to their larger size. To normalize for size, the inversion of the disintegration rate was taken to determine the time it took to disintegrate 1 millimeter of each product. These results once again indicated that our products had superior disintegration characteristics compared to the carbohydrate market product. The current market of in-mouth dissolving snack products is carbohydrate-based and greatly lacking in ability to be a good long-term satiety source. And using either skim milk or lactose hydrolyzed skim milk in combination with milk protein concentrate powder as the primary ingredients in these fast dissolving puffs, a product can be made having the ideal nutritional profile either for infants or older adult population. In infants, a high-protein snack product containing skim milk powder is more nutritionally ideal than the carbohydrate-based puff because the lactose in the skim milk powder is the most nutritionally dense carbohydrate for infants, and the high protein content will prevent a rapid blood sugar spike, which could occur with a carbohydrate-based product. In the older adult population suffering from dysphagia, the importance for a high-protein, easy-to-consume product is important because this population benefits from consuming higher protein than recommended for younger adults to help prevent muscle and bone breakdown that occurs with age. Difficulty with chewing and swallowing are a major barrier for this population in meeting these protein consumption goals, which is where the in-mouth dissolving lactose hydrolyzed skim milk powder based puff would be ideal. The lactose-free skim milk product would also be ideal for this population because 70% of the world is lactose intolerant, so making a product that is high in milk protein content without being high in lactose is very needed. Samples were also analyzed for soluble prebiotic fiber galactooligosaccharides, also known as GOS. Comparison of milk protein-rich samples before and after extrusion indicated that the formation of GOS during processing of these products. GOS has currently been supplemented in baby food formula because it very closely resembles human milk oligosaccharides, which play a huge role in the maturation of the infant's brain. These cognitive benefits in GOS are currently being researched for older populations and indicate that there are signs of improving cognitive function and mood linked to the consumption of GOS. This makes GOS an increasingly important ingredient to investigate inexpensive production methods for, because it can not only improve the health of our younger generations, but also our older ones.